Hello Math 20-2 and welcome back. Today we're looking at quadratic functions and using pictures or word problems without an equation in it, but normally we're given a picture to solve for the quadratic equation, or else we'll have to draw a picture and then try and figure out what's happening, okay, and then use the quadratic equation to solve certain parts of the question. So right here, our first question, we're looking at the San Francisco Bridge, or the Golden Gate Bridge in San Francisco. Now, I'm just going to skip ahead to this part here where we get to the information about the bridge. First thing it says, this point here is 0, 0. So that's my origin. So here's my y-axis, this is my x-axis. And we know this is 746 feet above the water. So from here to here is 746 feet. Okay? The bridge is 246 feet above the water. So from here is 246. So then only from here to here is going to be, well, 746 is this whole distance, 246 is this distance, we have to subtract them. That's only going to be 500. Okay? Now we keep on going. It says there's 4,200 feet apart. The towers are 4,200 feet apart. So if this point is 0, 0, this point here is 4200, 0. Alright? Now we continue this. It also states that the lowest point of the cable, and it's a parabolic cable, so that means a parabola, it's a quadratic, is 10 feet above the ground, or the road. So this distance here is 10. So the lowest point is the vertex. And it's 10 feet above the road. So now it says state the coordinates of the top of each tower and the vertex of the parabola. So the top of each tower. So let's take a look at the left tower. I'll just put LT for left tower is equal to, well, I have, these are pretty much my x-intercepts, my towers. I have 0, 0. So this one's equal to 0, 0. And my right tower is the whole thing, the whole bridge is 4,200 meters long, and we're starting at 0, so we go. So that is my right tower. Now we want to know the vertex. Well, my y value of the vertex is fairly simple. It is right here. It is this point here. So we have this bridge is 500 meters down, right? That we found out over here. Because all the way to the water is 746, and there's 246 above the water, so it's 500 from the top of this tower to the road, or the bridge. Now, it is also, this cable is 10 meters above the road. So then I have to go 500, subtract 10, to give us 490. And it's below my x-axis, so it's negative 490. So I know my second part is negative 490. That is my y value. Now let's try and find my x value. My x value is right in between these two. So I have to, if you remember, to find your x value there, or this is going to be your asymptote, it's right there, what we have to do is we go add our two x's together, so 0 plus 4,200, and then we're going to divide it by 2, which will give me 2,100. Okay? So I have 2,100. Alright. Next part, part B, says the equation of the function of the parabola can be written in this form here. Which form is that? That is factored form, where m and n are my x-intercepts. Okay, so it wants it in factored form. Determine the values for m, a, m, and n, and show that the equation of the parabola is that. Okay, so first is first. We have to determine the values of a, m, and n. So let's plug this in. We get y is equal to a, and I have x subtract, well, 0, because I'm doing left tower. And then my right tower is x subtract, and my other x-intercept is 4,200. Bracket. Okay? All right, so in other words, what's x subtract 0? That's just x. So I get y is equal to x, ax, x subtract 4, 2, 0. Now, my problem here is at first is I need to solve for a. I don't know what a is. But do I know another point on the graph? Yes, I do. I know the vertex. So that's another point on the graph. So I could put this in for x and this in for y, because I know a y and x value besides the two we used on the graph. So let's try that out here. So my y value is, sorry, where is that? Right here, negative 490 is equal to, I have a, and my x value is 2100, 2100, and I go 2100 minus 4200. Okay, so I do a quick calculation. First I'm going to subtract this. This is going to give me a 2100 multiplied by negative 2100, and we have negative 490, and this is squared. So if I do that, that's 441000a. Okay, I think that's right. Now I go 490 divided by that. And this is negative, by the way, because negative times a negative. Okay, because we're just isolating for a. And we put that in my calculator, and or simplify it best I can. I am going to get 1 over 9. I'm just going to double check it here. So let's try 490 divided by 4414. Oh, and I'm going to put that in my fraction. I get 1 over 9,000. The reason why I put in fractions is because this part here is in fractions. Okay? So now it says it wants it in this form. Show that that equation is similar. So let's rewrite my equation here. So I get y is equal to 1 over 9,000. And I have x, and multiply by x, subtract 4,200. So if we look at this here, there are no brackets. So let's try and get rid of my brackets. I'm going to multiply this into that. So x times that, x times x is x squared, 9,000. And then I have to go minus this multiplied by that, which is going to give me 4200 x all over 9,000. I'm pretty sure that can be simplified, so I check that out. Let's see, 4200 divided by 9,000 gives me math, fraction, 7 over 15. So we get x squared all over 9,000 minus 7 over 15x. So we get the exact same answers they had. And there we go. Okay. So now let's take a look at C. C says, state a suitable window for graphing the equation in B. Use your calculator to verify that the coordinates of the vertex. So if I want to make a window here, let's take a look at this. We have 0, 4,200, and we go as far down as, let's say, 500. So for my window, let's see my x. We go from 0, x min, I'm going to say is 0. But I'm going to make it a bit bigger, minus 10. My x max is 4,200, so I'm going to say 4,300. I'm actually going to put minus 100, so we have a little bit more range. So I'm 100 over to both sides, because look how big it is apart. And I'm going to count here by 150s. Okay, so it's counting by 150 every time. My y min, my y min, well, I have 490 as my vertex, so I'm going to go a bit lower. I'm going to say maybe 600. Okay, my y, oops. my negative 600. My y max, I'm going to say, well, yeah, we can stay at 15. Or maybe I'm going to say 50 for this. Just so it's a bit above so we can see. We can have a, and I'm going to count by, this one I'm going to say 50s. Alright, so let's go to my y equals, put in my equation. I'm going to have, let's see if we can see this here, x squared. Oh, so I'm going to first put in my window. So coordinates, calculate, verify the coordinates, same as in your answer in A. So suitable window would be, let's try this, negative 100, 4,300, and 150. And let's try negative 600, 50, 50. Okay, so those are that's my window. Now I want to graph it. Okay, so clear this. And I'm going to put this in. So I have x squared divided by 9,000. And I'm going to put that in bracket. And that is subtract 7 over 15. And I have my x. So there is, oops, probably didn't even see that. Sorry about that. So then there is my graph. So notice how I put in my brackets here. I really made sure my brackets are in properly. I put everything in brackets to do this. And I get like that. And look how nice that is. I can see everything. Okay. So there we go. Now determine the height of the parabolic cable above the road at 900 feet. So when the road is 900 feet here, we want to know the height of the parabolic cable. Alright, so above the road, determine the height of parabolic cable above the road at 900 feet from the left tower. So we want 900 feet from the left tower, so that's when x is equal to 900. So we go trace 900. So I am down 330 feet. So if I look at that, at 900 we are at is equal to 330 feet below our tower. Now, our tower is 500 feet above the bridge. So I go 500, subtract 330, which will end up giving me 170 feet. So it's 170 feet above the road. So road is 500 feet, and this is from the top tower, and this is 330 feet from the top tower, so it's 170 feet. Okay, so the last one says, write the equation so it can be written in standard form. So standard form, if you remember, is given our vertex. So y is equal to a, well we know a was found out before, that's 1 over 9,000. Okay, and we have x subtract, well this is my x value, h is your x value of the vertex, which is 2100, and that's squared, and then we're adding a negative 490, because it's my y value of the vertex, which we found out before, and that's it. Okay, so last question here is example 2. It says, the cross-section of a satellite dish with the parabolic measurements are as stated. So the Cartesian plane is superimposed on the graph with the origin in the middle, okay? The maximum depth of the dish is 8 centimeters. So here's my origin, it's at the vertex. So we know my vertex is the origin. And my maximum depth is 8 centimeters. Now, it says here, if the maximum depth of the dish is 8 centimeters, determine the width of the dish to the nearest tenth of a centimeter. And we also know it's 14, it's there. So this point here is 14, comma. Now, this isn't quite 6, this isn't 6 high. If this is 8, this is 14, comma 2. So that is this point. That's a point we know. And we know my vertex. So I'm going to use the equation for vertex form. Since that's the only one we know, we're going to have to use my vertex form equation. So we have y is equal to ax minus 0 plus 0. And that's squared, right? So that just gives me y is equal to ax squared. Now we have to figure out what this a value is. And in order to do that, I need to know a second point or another point on the graph. Well, my other point on the graph is this one here. Now remember how I got the 2? Because if it's 6 away from this part here, which is 8, then this distance here is only 2. So I have my y value, I know on this graph, my y value is 2, my x value is 14. Okay? So when I do this, I'm going to get 2 is equal to 196a. So in other words, a is equal to 1 over 98. Okay? If you plug that in a calculator, you're going to get that. So, let's take a look at this now. It says determine the width of the dish. So now we want to know the width of the dish. So it's a maximum 8 centimeters deep. So then this here, we want to know when the height is 8, and this height is 8. Well, so we know what the y values are. It's when it's 8. So 8 is equal to, now we know my a value is 1 over 98, and then we have x squared, which is the same as x squared over 98. So now I have to solve for x squared. So what I'm going to do is I am going to multiply both sides by 98. Okay, this one I can't quite do in my head, so I have to go 98 times 8, which is 784. Actually, I could have done it in my head, it wasn't that bad. 784 is equal to x squared. So now what I must do is solve for x, I square root it, so I get 784 square root 784, which gives me 28. Now that is also plus or minus 28. So it's 28, because I could have negative 28 times negative 28 gives me 8 as well. So this is 28 away, and this is 28 away. So my whole distance is 28 and 28 is 28 times 2, or 28 plus 28, which will give me a total of 56, here we go, 56 centimeters away. So that is the width of my disc. So this is a fairly complicated lesson, but hopefully understood, as we see you tomorrow as we work on this together.